All right, so we've looked at voltage, current, and resistance and learned a little bit about the characteristics associated with them. Now we need to look at how we put all of these together to form something called the electric circuit. So we're going to look at the basics. We're going to start learning how to relate them to something called the schematic diagram and a physical layout on a circuit board. We're going to define open circuits and closed circuits, various types of protective devices and switches, and we're going to look at how wire sizes are related to gauge numbers, and then finally define ground, which is very important for safety issues and making a circuit work. So if we look at an electric circuit, we need to start learning something about a convention. So today there are two accepted conventions for the direction of current. Electron flow direction, preferred by many of the fields of electrical and electronics technology, assumes, for analysis purposes, that current is out of the negative terminal of a voltage source, through the circuit, and into the positive terminal of the source. Conventional current direction then assumes, for analysis purposes, that current is out of the positive terminal of a voltage source, through the circuit, and into the negative terminal of the source. By following the direction of the conventional circuit, there is a rise in voltage across a source, negative to positive, and a drop of voltage across a resistor, positive to negative. So whichever convention you're used to and use, the key is stick with it. Pick one and stick with it. So let's look at an example of a simple electric circuit with a source, a battery, a lamp, which is a load, and then the connecting wires. The electric circuit schematic then, an electric circuit can be represented by a schematic using standard symbols for each element. For simple circuits, a schematic in an organized manner shows how the various components of a given circuit are interconnected so that the operation of the circuit can be determined. Now, the thing to keep in mind is this schematic representation may not exactly match the diagram or the circuit board layout, but virtually it will be the same because the positives, negatives, and leads will connect accordingly so that this is in fact true. So if we look at closed and open circuits, again, now we're looking at something that's a little lower than that of the schematic diagram. We've got a battery or a source, a light bulb, and an on-off switch. And so we're going to look at, by putting the switch in there, what creates an open and a closed circuit. So in this case, we turn the switch on, and current is allowed to flow, in this case from the positive terminal through the switch, through the light bulb, and back to the source. So this is considered to be a closed circuit. If we turn the light switch off, we in essence have broken the circuit, we've opened it so that current cannot flow. If we look at the schematic diagram, we have an open switch. Okay, so if you haven't thought about this or haven't seen this before, this is something you need to get in your mind in terms of open and closed circuits, and in this case, with a switch. Now let's look at something a little more sophisticated. Let's say we have a switch that's something called a single pole double throw switch, where we can determine which light bulb comes on and will direct the current through the appropriate light bulb. So we can see here, as we switch between 1 and 2, it's going to allow current to flow into the lamp. You'll notice that the opposite side of each of the lamps are connected together to the same negative pole. On the positive side, the current comes into the switch and then is allowed to go into whichever direction the switch is set to. So if we look at the schematic diagram, we can see maybe a little simpler what is in fact going on here. You can see we have a single pole, a double throw. So in position 1, lamp 1 comes on. In position 2, lamp 2 comes on. Basically, an electric circuit then consists of a source, a load, and a path for the current between the source and the load. The diagram shows a pictorial form, an example of a simple electric circuit. Okay, so if you go through here and look, you can see we've got a lamp identified, we've got a conductor, probably a copper wire, and we've got a battery or a source. Current goes through the filament of the lamp, which has some resistance. There's always some resistance. You've always got some sort of loss in a circuit. It causes it to emit visible light. Well, there's your loss. The light, the wire starts to heat up, it turns to heat, and you now have a loss occurring or a resistance. Okay, and the thing to keep in mind, in a battery like this, sometimes we call them dry cells. The battery operation here, creating the current, is a chemical action. So if we look at different types of switches, you can see you can set up a switch for virtually whatever type of circuit you think you may need in controlling, in essence, the load. The load would be a light bulb in this course. So we have single pole, single throw, single pole, double throw, double pole, single throw, double pole, double throw, and then this one on the bottom here, which is actually is a press type, normally open, and a press type, normally closed, which opens or closes the circuit. And then we have a rotary position. So these are all switches that you need to become familiar with and what they actually look like in their physical sense. Some examples here, again, toggle switches, rocker switches, push button switches, switches mounted on PC boards, dip switches, which are small micro switches, and then rotary switches. The thing that we're going to learn as we go through the courses in your degree program here is that something called a semiconductor switch. A semiconductor switch is actually an electronic switch that turns a circuit path on or off depending on how you bias the circuit. Okay, this is something you just need to be aware of. You don't need to get too buried in it right now, but be aware that this is one of these areas where we're looking forward and trying to determine where is this all going in terms of electronics. So in this case, we've got some bipolar transistors, and over here we have some field effect transistors. And later on in your solid state classes, you're going to learn more about how each of these transistors operate based upon the bias to the circuit. Fuses and circuit breakers. There are all types of fuses and circuit breakers that can be used in electronics, and they will all depend on whether it's something you want to be able to reset manually and fairly conveniently, or something in a very large current environment where you may need to actually reload a new fuse. You can see the diagrams here, a fuse symbol versus a circuit breaker symbol. All right, in the next section here, we're going to take a look at wires and wire gauges and see why there's a difference in the types of cable and wiring that you use in a given circuit depending upon the amount of current.